Do you want solid state devices polluting your hollow state amps? Sand mixed in with your vacuum? Silicon with your metal and glass? Solid state devices in your tube amps? Welcome to Lancaster Hi-Fi. I'm Stephen Lancaster, and I want to talk today about the role of solid-state devices in tube amps. While I remember here at the beginning, please subscribe to the channel. Come on. It's not hard. You can do it. It'll help. It's just does my heart good, even if my videos only get, 1,000 views. It's just nice to see that subscriber count creeping up towards 10,000. And it'd be nice to see it creep a little faster. That's all I'm saying. All right. So what do I think about putting solid state devices in tube amps? Well, why wouldn't you? I mean, hell, even if you do put them in the signal path, sometimes they let you do cool things. I was talking with my friends the other night how people like tube rectifiers. And it's sort of like, why? And they're like, oh, it's the sag. It's like, so you want a saggy power supply? That's a good thing? I thought a stiff power supply was good. I mean, don't get me wrong. I use tube rectifiers and I've used tube rectifiers in all of my amp builds, and I'm fine with tube rectifiers. There are advantages actually to tube rectifiers, especially the 5AR4, which takes a while to start passing current. And because of that, allows the tubes to get good and warm before high voltage hits the plates. If you're going to do it some other way, if you're going to figure out some other way to have that same effect, it could get complicated. I don't have a problem with tube rectifiers, but if I want to hit a certain voltage and I'm stuck with a certain power transformer, I'm going to use silicon, because a 5AR4, which drops less voltage than a 5U4GB, still drops a lot more voltage than a diode. So diodes in rectifiers are an excellent use of solid-state technology, solid-state devices in tube amps. But I don't stop there. Some of you who are familiar with tube amps may be familiar with a bit of hum. Not a lot, not so you notice when the music's playing, but you kind of notice it when the music stops playing, don't you? My Heathkit hums. I've got plans for it that include solid-state devices to get rid of that hum. So, the straightforward way to get rid of that hum is to regulate the voltage to the input and phase splitter stages. That is, the voltage supply, regulate the voltage that goes to that first tube, the small tube. In a push-pull amp, you don't need to worry about the big ones because of the push and the pull. The hum cancels out. So you can have, I'll show you, 3 volts RMS of ripple on your high voltage, and that's not going to come out of the output stage because it cancels. But if you put that kind of ripple on your small tubes, yeah, you're going to hear that. So when you've got a hum on a push-pull tube amp, that's what you're hearing. And the reason it's not very loud, like 3 volts transformed, anyway, the reason it's not very loud is because after the B plus that goes to the output stage, there's another dropping resistor or two and a capacitor or two to further smooth out the voltage, to further smooth out that ripple. Low pass filters, a resistor capacitor, that's a low pass filter. You put a couple of those in and you reduce the ripple by quite a bit. Tube amps don't typically have super effective low pass filters like you find in solid state amps. So yeah, you're gonna get that hum unless you resort to a solid state device. And then there's a couple of options. A couple of things that I've done. One is the simple voltage regulator. Put a high voltage regulator to drop from, say 320 to 285, for example, or from 400 to 350, for example. And then you essentially eliminate that ripple. You go from, the 3 volts RMS on your highest voltage supply to effectively nothing. The other option is a capacitance multiplier, which can also be rigged to act like a regulator with a Zener diode. I've typically not used a Zener diode simply because I'd have to stack them up, and getting the voltage just right would be tricky. Instead, I've used just a voltage divider where the base of the transistor is coming out of a voltage divider that is going to drop that voltage by a certain fraction. And it's not regulated because if that high voltage does sag, then so will the voltage that comes out of your capacitance multiplier. But that, whatever. That's not that big a deal. Or at least maybe it's not that big a deal. I mean, hell, if you were using a regulator and your voltage sags enough, depending on how much you're dropping in your regulator, it could go out of regulation. And then you'd put all that noise of the high voltage right through your regulator. But I digress. A capacitance multiplier, essentially, you put a pretty big low-pass filter on the base of a transistor, a BJT, bipolar junction transistor, and you essentially amplify that low-pass filter signal, or lack thereof, drop to the emitter, and so as long as you've got a big enough drop from between your collector and your emitter, and you essentially drop the voltage out of your capacitance multiplier below the level of that ripple, then you get super quiet high voltage out of your capacitance multiplier. And it's not, capacitance multiplier is what it's called, but it's a bit of a misnomer because it doesn't actually multiply capacitance, but it sort of seems like it does. Sort of amplifies capacitance in a weird way. Anyway, capacitance multiplier is the name. Very handy device to know about. It just takes one transistor, maybe two if you're trying to pass more current. But I figured out that since I'm only using it to supply my small tubes, I can use a pretty, just a regular, I can use if you're familiar with transistors, a KSC 1845, which I think it can only do like 50 milliamps, but that's typically plenty for a couple of small tubes for, say 4 triodes, especially 12AX7s. For my Beaver Valley, I think I ended up using 2 regulators in parallel. because just using one burned up that regulator. Partly because the Beaver Valley uses those 6DJ8 family tubes, and those draw quite a bit more current than, say, a 12AX7. 12AX7 may only draw 1 or 2 milliamps at idle, whereas a 6DJ8 family draws more like 10. So, get per triode, so a couple of 6DJ8 family tubes, that's 4 triodes, that's 40 milliamps. A high voltage regulator, if it's dropping like 50 volts or something, that's a lot of power through that thing. Anyway, that's a great use of solid state devices in a tube amp to make the tube amp sound better. Eliminate that hum from the power supply. My Beaver Valley amp is just dead silent. It's awesome. So this is a tube amp that I'm trying to finish the build of. This chassis came out of a jukebox. It has 4 7868 tubes and 2 12AX7s and a 5AR4 5AR4. Now, it has a couple of solid state devices. Well, actually several. But the major ones are, back here is a negative voltage regulator for the bias power supply, because this has fixed bias. And right here is simply a transistor, which is part of what is known as a capacitance multiplier. What the capacitance multiplier does is make the power output, which is where I've plugged this red alligator clip to, that's the emitter, makes that voltage super, super smooth. So it's not a regulator, but it'll typically drop a relatively pretty fixed amount of voltage between collector and emitter. And the voltage at the emitter will be very quiet, because it essentially amplifies a very quiet voltage at the base. I recently had to replace this transistor because the old one was damaged by overvoltage. So normally there is a relatively small voltage drop between collector and emitter, but during power up there can be a relatively large difference between collector and emitter, and I think the maximum allowed voltage difference is 150 volts for this. I think this is a KSC 1845. And if the voltage difference exceeds that 150 volts, the transistor goes kablooey. I mean, not literally kablooey. In fact, it'll look like nothing's wrong. It'll just act like 2 resistors instead of a transistor. In order to mitigate this issue, I've stuck a 100 volt Zener diode between emitter and collector. So the diode is pointing from emitter to collector, but that, since it's a 100 volt Zener, that means if there's more than 100 volts, or there gets to be 100 volts difference between collector and emitter, then current will flow through the diode, thus protecting the transistor. So that diode will only conduct during startup, but we're going to look at it on the voltage meter here. I've got a probe connected to the collector. No, I've got a probe connected to the emitter and one connected to the collector. And in fact, I misconnected those. I need to reverse those because the higher voltage will be at the collector, which is here. And the lower voltage will be at the emitter here. So rather than look at voltage relative to ground, we'll be looking at the voltage difference between those 2 points. All right, plugged into regular power. Let's check it out. See, we got to 100. And it stops, and then it should drop to, what should it drop to? Probably maybe 30 volts. I'd have to check the schematic. If I wanted it to act more like a regulator, I could stick another Zener diode. I could stick a Zener diode, or more likely a few Zener diodes, on the base, pointing from ground to the base, and those would hold the voltage at whatever the Zener voltage was, or the combined Zener voltage of the diodes. So for example, if I wanted it to be 200 volts, I could take two of these 100-volt Zeners and stack them between ground and the base there. If I wanted 300 volts, I could stick 3 of those 100-volt Zeners. Okay, so it looks like we've got voltage. The voltage drop is slowed way down. It's going to approach that final voltage and never quite get there. And so whereas the voltage on the collector will be up here, the voltage at the emitter is approaching a fixed voltage difference between the two. And the closer it gets, the more slowly it approaches until the difference is immeasurable. That is, the change is immeasurable. The difference should be effectively constant. And that change is looking like about 42 volts. The difference is about 42 volts. The change is quite slow, but still proceeding to drop. Sort of. Or is it just fluctuating now? All right, I thought it would be useful to look and see what the capacitance multiplier does to the voltage ripple. This is the B plus up here, but we're just looking at the AC component. It has 3.2 volts RMS of AC ripple on it. You can see 120 hertz because of the rectification of 60 hertz. Now, we don't really hear that because due to the push-pull tubes, the ripple cancels on the two tubes in one channel, so we don't hear it there. But if we put that kind of ripple on the input stage, we would definitely hear it. So we will typically have additional steps down and additional capacitors to quiet that voltage. But typically in a tube amp, we don't get it super quiet. You notice this flat line here. Well, we're looking at the emitter of the capacitance multiplier. And note the scales here. The scale on A at the B plus, that's a 2-volt scale. The scale on B, which is on the emitter, which is the power supply going to the 12AX7s, that's a 50 millivolt scale, and I'll make it smaller still so that we can see what ripple there still is, if it's even measurable. Okay, now the other thing I'm going to do is change this reading so it'll give me the same sort of volts RMS as the other side does. So let's see, change reading to, put it on to B, and make it volts AC, and clear the menu. to get things calmed down here. These probes are kind of wonky. There we go. So, on the B plus, we have a ripple of 3.2 volts. On the secondary B plus, we have a ripple of 0.3 millivolts. As a result of that very small amount of ripple on that secondary B plus, that's not going to be audible. Yeah, just not going to hear that. So this amp, once it's working properly, should be pretty much silent without a signal. And that is what solid state can do for your tube amp. There are some other uses of solid state devices that are very much worth mentioning. And I've learned about these uses through my research in preparation for building the so-called Simple 45 based, or the TubeLab SE2 amp, which will use these small 5841, anyway, uses a small triode and a 45 tube on the output. In between those, it uses a, what does he call it? Power boost. Something. Anyway, he has some name, and he being George, and I can't remember his last name, the TubeLab guy. So he just sticks a big old FET, I think it's a big old MOSFET between the input gain stage and the output stage, and simply uses it as a source follower. Yeah, so FET has, okay, BJTs, transistors have, bipolar junction transistors, BJTs, have collector, like this, collector, emitter, and base. And a FET, field effect transistor, has source, gate, anyway, I can't remember. It feels so stupid. It's gotta be the booze. Anyway, source follower is just like an emitter follower, is just like a cathode follower. Same idea. It's a unity gain device, that unity voltage gain, but you can gain a lot of current. And in the TubeLab SE, you put that source follower between your input stage and your output stage, and you don't have to worry about your input stage providing enough current to the output stage. You don't have to worry about the slew rate of this tube showing up as slewing distortion in your speakers. It's amazing. It's like a magic bullet. You can use whatever tube on the input you want for its gain and its sound. You can use whatever output tube you want for its gain and for its sound. Simple MOSFET in between. I mean, it's not super simple. There's something to the circuit, and it's like, yeah, you're just putting a current source, essentially. It just passes the signal straight through. It's wonderful. I've heard I've had people comment that you could do the same kind of thing with op amps. With an op amp, it'd just be called a voltage follower. The last use of solid state devices is that I know of is as essentially a current source. Leave a current source to the plates of your small tubes. And this is, again, something from the Tube Lab SE. So that your input stage operates at constant current. So whereas with simply using a resistor as a current source, because the resistor is a simple current source, your load line is like this, right? At zero current, you've got your, the full voltage of your supply, and at zero voltage, you've got all the current. And the trick of designing any tube stage is to get that load line just right. Well, if you use a constant current source, your load line's now a flat line. That's a lot simpler. You just put it wherever you want. Pretty sporty. So, is that the last use of a solid-state device in tube amps? I mean, we can talk about true hybrid amps, where you have, for example, I think probably the most common would be having a tube preamp stage and a solid-state output stage, which will give you your nice tubiness in the preamp and let solid state do what it's particularly good at, which is providing lots of power relatively cheaply and cleanly. So that's an actual hybrid amp. But the uses that I've been talking about so far are not hybrids in any real sense. These are tube amps. Simply employ solid state devices to make the tube amplification work better. And even the most purest tube amp lovers out there can get behind that. How do I know that? Because the most purest tube amp lover that I know is the one who clued me into the Tube Lab SE. Cheers, Nick. Yeah, you can have hybrid amps. You could do the other way around. I mean, like I use separates, and I don't have a tube preamp, so I use solid state preamps and tube power amps. That's a hybrid of sorts, right? I mean, it would be a hybrid if it were integrated. I've talked about regulation. Well, you can also use regulation if you have a fixed bias where you need a negative voltage supply for your grid. Fixed or grid bias needs a negative voltage power supply, and you can put a regulator on that. And now we have, again, the B plus ripple and the ripple on the bias supply, which is coming in at a whole 0.0 millivolts. Neat. So, there can be a question of, should I have used a regulator up here on that secondary B plus as well as a regulator here? And in my Beaver Valley amp, I have used a regulator, but I ran out of those regulators and tried using capacitance multipliers instead, and they seem to you know, if you really want regulated voltage, that's cool. You can do that. But it's the real purpose of the regulator there is to remove hum, and that capacitance multiplier does that nicely. Oh, and I was reading today, about a design that regulates the supply to the screen of the output stage pentodes. And supposedly it gets really nice results that way. The Tube Lab, I forgot like one or two more uses for solid state devices. Again, for regulation, the Tube Lab SE in order to use the 45 tube takes, say, the 6.3 volt AC that you'd normally find on a power transformer and, rectifies that and whatnot. Rectifies it and then puts it through a regulator to get 2.5 volts for the heater, the filament, which is also the cathode in the 45 tube. So DC to the cathode, which is also the heater. George reports that improves the sound. I think you eliminate some sidebands on notes. So distortion, harmonic distortion. Some people swear by using AC on heaters, and that's fine. I can't remember whether the Tube Lab SE bothers trying to regulate the supply to the heater on the input tube. Maybe. Can't remember. Or for the rectifier, I can't remember if it regulates that, if it uses DC for that one either, but I do remember specifically that it uses DC for the 45 output tube. But all those heater voltages are places you could use regulators. And that would also get around issues of, vintage amps. Say you've got a vintage amp and its power transformer is designed around 117 volt AC mains and results in a 6.3 volt supply that's more like 7.1 volts. And that'll work. It's not, your tubes won't instantly vaporize, but you will definitely shorten the life of those tubes by putting in over spec voltage. So rectify that voltage, put in a regulator, step that down to 6.3. You might need a low dropout or LDO regulator, but does exist. Those are a thing. Need a relatively high current one too. So, but those are a thing too. There's just lots of solid state devices out there waiting to be used to make our tube amps sound better. And why not? Again, you can go, oh, I just don't like the sound of transistor amplification. And that's fine, because you're not using transistors for amplification in any of the uses that I've talked about today. Grid bias supplies typically do already use diodes, even in the old designs. In the very old ones, they used selenium diodes, but diodes nonetheless. So solid state devices have been around with tube amps for a long, long time. My Heath kit uses a solid state rectifier for the high voltage and a single diode to rectify the fixed bias, the grid supply. Still bugging me. I can't remember that, what all 3 pins on the FET are. Oh. Well, I hope you will have subscribed to the channel already. And if you haven't, please do so. Please give a thumbs up to the video. Leave me a comment. What do you think? Do you have a particular sort of philosophy about the use of solid-state devices in tube amps? Is there something wrong with that? Does it somehow put sand in your sound? Have a good one, everybody, and I'll talk to you later.